So I often get the question, is plasma hot or is it cold? Before I answer such a question, I have to clear away the thing that makes this question so confusing. The glow, the glow, the glow we see in the plasma bulb. When most people picture plasma, they picture a bright, burning, glowing thing, and so they assume it must be always hot because it looks like fire. It's, amber, orange, red, yellow, just like fire. But the glow is misleading, and seeing why is the key to the whole answer. Here's the surprising part. The glow of a plasma is a side effect. It is not the plasma itself. When electrons in a plasma settle onto atoms, they release a little light, and that is the glow you see. But that glow tells you almost nothing about how hot the plasma actually is. A plasma can glow brightly and be searing, or glow just as brightly and be barely warm. The light it gives off and the heat inside it are two separate things. So first thing to let go of is the idea that plasma is the light it emits. It's not. The light is only a signal, and the plasma is the charged matter underneath. It's the field. And that matter can run hot or can run cool almost regardless of how much it glows. So once you separate those two, the real answer becomes simple. The rest is a distinction most of us were never taught. Temperature is how fast the individual particles are moving, and heat is the total energy they can actually deliver to you. And those two can be separated. Again, temperature is how fast the individual particles are moving, and heat is that total energy they actually deliver to your body. There are two kinds of plasma. A hot plasma, like the sun, everything is scorching. But in a cold plasma, like the plasma unit, the energy is deliberately lopsided. The tiny feather-light electrons are made very fast, so by temperature they're extremely hot, but the heavy particles, which carry almost all the mass, and so almost all the real heat, stay close to room temperature. So the plasma is fully active, and it glows, and does the real work, but the substance as a whole stays cool enough to touch. It is bright without being burning, alive with energy, and gentle to your hand if you touch the bulb. That is not a technically hard to thing to understand. It is the whole reason plasma can come indoors into rooms where we live, near skin, near a person. A cold plasma can be energetic enough to be useful and cool enough to be completely safe in the same space as you. The picture of plasma as a piece of the sun is simply wrong. The truer picture is a state of matter that can be, at the same moment, glowing and cool. Now, here is your way to notice this in the art of noticing plasma, and it's a small shift that we can all see. The next time you look at anything glowing, a candle, flame, a screen, a neon sign on the road, try to separate two things in your mind, usually that we fuse together. There is the light it gives off, and then there is the thing that is giving off the light. We almost always see only the glow and forget the source. Part of cultivating the art of noticing plasma is learning to look past the light to the matter making it. Once you can hold those two apart, you will understand something most people never do. That a thing can shine and still be cool. And that brightness was never the same as heat.